Okay, today we're going to talk about vectors and dot products. A dot product is a operation like multiply, divide, subtract, add, square root, sine, cosine, that kind of thing. And it has its own definition. And basically, when you're talking about the dot product of two vectors, that means that you are going to multiply the first two things that you see in each vector, so u1 and v1, and then add that to the second things, u2 and v2. If, for some reason, this thing turns out to be 0, then your vectors are orthogonal, which means that they are perpendicular. And the interesting thing is that this dot product turns out to be a scalar, which means the same thing as a number or a constant. So you probably should write that down. The word scalar means that it's a number. Let's try a couple of examples. Example number 1. If I take the dot product of these first two vectors, that means I have 3 times 7 plus 5 times negative 5. Or in other words, I get negative 4. In letter B, oh, by the way, we find out that since this is negative 4 and not 0, the answer is no, they're not orthogonal. In part B, we have 2 times 3 plus 3 times negative 2 for a total of 0, which means that yes, these things are orthogonal, or in other words, perpendicular. And in part C, we have negative 5 times 5 plus negative 6 times 6, or in other words, negative 61, which means no, these are not orthogonal. In number 2, we're going to do the same thing, just find some other answers. So in number 2a, we're going to take the dot product of u and v first. So u and v dotted would be 3 times 2 plus 5 times negative 1. And then we're going to multiply that by the w, 2 and 1, which means I'm going to have, from the parentheses, 6 plus negative 5, which is 1, times that vector 2, 1, which means I end up with the vector 2, 1. Looking at B, I'm going to take the u vector, which is 3, 5, and I will dot that with twice the v vector, so that would be 4, negative 2 if I have twice that vector. And if I dot that, I end up with 3 times 4 plus 5 times negative 2, or in other words, positive 2. And then in u.v and v.u, they want to talk about the commutative property of the dot product. So if I look at the dot product between u and v, this would be 3 times 2 plus 5 times negative 1, which gives me 1. And then I could also look at the dot product of v.u, so going backwards now, and that would be 2 times 3 plus negative 1 times 5, which is also 1. And what they're trying to show us is that these two things are the same, or in other words, the dot product is commutative. In our next slide, we talk about one of the properties of the dot product. And what they're saying is if you take the dot product of the same vector with itself, you get the magnitude, or in other words, the length squared. So for example, if I look at the vector u and I write it in its component form, 16 comma negative 10, and I dot that with itself. So if I take u dot u, I would see 16 times 16 plus negative 10 times negative 10 for a grand total of 356. And on the other hand, if I were looking at the magnitude of u, which we learned the other day, what I know is that's the square root of 16 squared, which is the first piece of my vector, plus negative 10 squared, which is the second piece of my vector. And when I add those together, I get the square root of 356. And so what they're saying is if I take that blue answer and square it, what I end up with is 356, or in other words, the magnitude squared. When we're talking about vectors, oftentimes it's important to know the angle in between two vectors. So if I were to look at these two vectors and talk about what's happening with them and put them on a coordinate axes, I could draw what's happening with these two vectors. And so as I look at these two vectors, I have one that is vector v and one that is vector u. So the first vector, vector u, if I were to draw that on my coordinate axes, that's at 4, 2. So that vector goes over here, and in component form, that means it starts at 0, 0, of course. And if I look at vector v, which is 3, 4, that also starts at the origin, and 3, 4 means it's going 3 to the right, 4 up as it ends, which means it starts at the origin and looks like this. And what they're talking about is the angle in between theta that we're going to try and find. How big is that angle? And so the way that we do this is that we start out by talking about that the cosine of that theta is equal to the dot product of the two vectors, which would be 4 times 3 plus 2 times 4, all over the magnitude of u, which is the square root of 4 squared plus 2 squared, times the magnitude of v, which is the square root of 3 squared plus 4 squared. Now before I do this and find the final answer, what I probably would do is I probably would simplify a little bit before I type it into my calculator. So if I'm continuing on with this, I know that my cosine of theta is equal to 4 times 3, which is 12. 12 plus 8 is 20, so the numerator is 20. And in the denominator, if I look at the first square root, I have 4 squared, which is 16, plus 2 squared, which is 4. So that's the square root of 20. And in the pink, I have the square root of 9 plus 16, which is 25. Now I could simplify that a little bit more. And if I were to write down maybe what those two square roots are together, I would have the cosine of theta is equal to 20 over the square root of 500. Now the reason I go to the simplification process is I think that it's kind of easier to type a couple things in your calculator without making mistakes. So if you recall, in order to get rid of that cosine and just find the theta, theta is going to be equal to the cosine inverse of whatever you had. So that would be the 20 over the square root of 500. Type that in your calculator and make sure that you have parentheses in the correct places. And what you find out is that the angle between those two vectors ends up to be 26.6 degrees. Make sure that you're in the degree mode and give that a shot. The last thing that we're going to do is we're going to determine whether two vectors are orthogonal, which means that their dot product comes out to be 0, parallel, or neither. And I think probably the most helpful thing in this situation would be to draw these two vectors. And before I draw them, I'm going to put them in their component form, because I think that's helpful as well. So if I write u in its component form, it would be 0, because there's no I there, comma 1, because there's a constant of 1 in front of the j. And the v vector would be a 1, comma negative 2 for the coefficients of the I and the j. So first of all, if we're looking to see if something's orthogonal, we can easily check that by looking at the dot product. If we look at the dot product to see if they're orthogonal, I would have 0 times 1 plus 1 times negative 2 for a grand total of negative 2. So they are not orthogonal because it's not 0. And then for the other things, I think it's actually helpful to see what these two vectors look like. So I'm actually going to draw them on a coordinate system. If I draw them on the coordinate system, what I would see for the red vector is that I have 0, 1 for that vector. So that means I have a vector that's going up to the 1 coordinate. And for the blue vector, the v, I have 1, negative 2, which means I'm drawing it like this. And just from the visual, you can see that it's going to be neither in the n as the answer, because they're not orthogonal, we already found out, which means they're not perpendicular, and they're also not parallel to each other. But one of the ways that you can actually figure this out without doing all that is you can check out the slope, because one of the cool things is that when you put something in its component form, you can see what those slopes are of the lines. You can look at the red line, you can see it's undefined, but the way that you would figure out that slope, the slope of u that is you have to just put the y value over the x value, because you would have 1 minus 0 for the rise, and then 0 minus 0 for the run. So in other words, the slope is 1 over 0, which are the two pieces of the component vector, the y over the x value. And then I can do the same thing for the v vector. The slope of the v vector would be its y value, negative 2, divided by its x value, for a grand total of negative 2, whereas for the u vector, this was an undefined slope. And you can see that these two slopes are not perpendicular or parallel, and that's why the final answer is neither. We are not going to do number 6 and number 7.